The views expressed on Skeptically Speaking do not necessarily reflect the opinions of the University of Alberta, the Students' Union, our affiliate stations, or CJSR.
Hello, and welcome to Skeptically Speaking, where we ask you to call in and question everything. I'm your host, Desiree Schell, and with me is on-air producer Sean Wimette, who's standing immediately behind Mike Harrison, who's training on the boards today. So, have you ever sat around and wondered about the possibility of life on other planets? I think we probably all have, at one time or another, probably while reading some science fiction or while watching a movie that made intelligent life a little more real for at least an hour and a half. But while you and I were daydreaming about it, other people were actually out there looking for it. And it's one of these people that will be on the show with us tonight. Dr. Maggie Turnbull, consulting scientist for NASA, will be on the line to talk about astrophysics, habitable stars, and the search for extraterrestrial intelligence. But first, we have someone here who'd like to do some speaking up. Jill Powell, member of Skepchick, the Skeptical Women's blog, and Boot Camp Survivor, will be discussing weight loss and diets. Welcome back to Skeptically Speaking, Lovey. So why ever would you target your skepticism at weight loss, Jill?
Well, one thing I noticed about weight loss and diet ads is that they're everywhere, especially in magazines and on television. You see these ads all the time, and it's really hard not to find one that's spouting a miracle cure for weight loss, unusual or restrictive diets, revolutionary exercise, or fat-busting devices or products such as pills, creams, etc. These ads are obviously very seductive, and let's face it, we have a tendency to be lazy. So if there's an easy way to do something, we're probably going to do it. But losing weight while staying healthy is kind of hard to do, and it takes commitment and actual effort. So these weight loss ads make promises of fast, permanent, or easy, and it's usually all of the above, weight loss. They have little to no scientific evidence that the product actually works, just a handful of testimonials that could just have been easily made up on the spot. Like, Liz from Tennessee says, "Oh, this worked for me." Well, who the frick is Liz from Tennessee? I want to know who this chick is, because why did this work for her? You could honestly make a drinking game of how many times you see the word miracle, scientific breakthrough, or secret formula in these ads, but then you would probably die of alcohol poisoning. Losing weight while staying healthy is important. To do this, people have to consume less crappy, less fatty foods and actually have to get up and be active. There's really no substitute for eating sensibly and hard work. It's not glamorous, but it's the one way that you'll see results without putting your body in danger. You can keep it simple. Find something you enjoy doing, and think about what you put in your mouth. If you need or want to lose weight, you should probably discuss this with a healthcare professional, like a dietitian or your doctor. Some of these weight loss products are a little sketchy and have some very serious consequences for your body if you take them and you don't know what's inside of them. Weight loss and diet scammers prey on the vulnerable people who have the most problems losing weight. They've tried exercising and eating less, and it hasn't given them the results they want because it's not a fast-moving process. It takes time to do. They're desperate to get the weight off, and they'll do whatever they can. And that's where the miracle creams, pills, and contraptions come in. And that's where the problems start.
So you mentioned you looked through these ads. I'm sorry. Did anything sort of stand out? Do you have any particular offenders?
Well, there's this one that popped up a lot, and I'm going to butcher the name, so I apologize in advance. It's called Hoodia gordonini, which is a natural appetite suppression remedy. This is a plant that grows in South Africa. It has been known to the indigenous populations of southern Africa who infrequently use this plant for treating indigestion and small infections. However, it is the century-old use of the meat of the plant, to suppress appetite when they're going on long excursions for hunting and whatnot, right. That stimulates most interest in the diet and weight loss community. But there has been really no concrete evidence that this suppresses appetites in humans. But, of course, that doesn't stop scammers from marketing it in a variety of formats to include pills, coffees, syrups, protein shakes, and even diet fruit bars. An interesting thing that I noticed when I was researching this was this herb is very dominant in the pill weight loss variety. It's a very dominant ingredient, but sometimes it's advertised, but it's not actually in the supplement. But because it's such a well-known one, they're like, "Ooh, it's in here."
But so they advertise it in the ad, but it's not actually in the pill itself.
Yeah. Weird.
Wow, that's 2 levels of crap. Okay, continue.
In March 2006, Consumer Reports investigated this dietary supplement and concluded that this weight loss drug lacks the clinical evidence for Consumer Report experts to recommend this product. So just because it's a plant, it doesn't mean it's good for you or that it'll do anything for you.
The naturalistic fallacy.
All natural does not mean cures everything known to man.
and the word natural does not necessarily mean good.
Exactly.
At all.
I
would just like to say black mold. Okay? Black mold.
Not
Very
good.
bad.
Not good.
Okay. Moving on. What about those weird, like, eat only blue food diets?
There's plenty of those. The one that I researched was the cabbage soup diet, which sounds as delicious as you can imagine. This is a heavy weight loss diet that is designed for the person to eat copious amounts of low-calorie cabbage soup over the time frame of 7 days. The typical claimed intent of this diet is to lose 10 pounds in a week, which most nutritional experts point out that it is nearly impossible to lose that much fat within a week. This has led credence to claims that much of the weight loss is water, therefore it's not permanent weight loss. First of all, eating cabbage soup for 7 days would be disgusting. Can you even imagine? Just eating 7 days of nothing but cabbage soup. That's gross.
But if it worked, it would be worth it for a lot of people.
It's true, but it's water weight. It comes back.
Wonder how long you'd have to eat cabbage soup for to keep the weight off.
Well, it's funny because this recipe for the soup has a very high sodium content, and the diet provides practically zero protein for several days at a time, so many people report feeling weak and lightheaded during the course of this diet. What's the point of doing something to yourself that's just going to make you sick and ultimately unhealthy? Isn't that kind of the opposite of what you want to do?
One would think. But you mentioned that these diets really target the people who haven't had any success with the whole eat less, move more plan. Mm-hmm. And people get desperate when they're vulnerable. This is really just an extension of other pseudoscientific crap that's on the market, right?
Right.
Because there's, when people are desperate enough to lose weight or to cure a disease or to get rich quick, their critical analysis seems to go right out the window. And you can't blame them. There's a lot of very intelligent people that just this is like a little black hole for them.
If they fall into the black hole, never to be heard from again.
Don't fall into the black hole, people.
You can't really blame people who, like you said, to get sucked into this whole weight loss madness. They want to lose the weight, and sometimes they pick a lousy way to do it. Sometimes the only bad thing that happens is nothing happens, and you just lose money.
Right.
But sometimes you are taking a health risk, and something happens to your body that's much worse than being overweight, and that's not something you want. The people selling these products are preying among the vulnerable nature and society's pressure that everyone must be skinny at all times, which realistically is impossible. Everyone's body type is different. Everyone's body responds differently to exercise and eating healthy, but and I mean, I'm not advocating being a size 0 because, I'm the farthest away from a size 0 that you'll ever see, but I try to be healthy and I work out, and I would never want to resort to something I didn't have the information on. And working out and eating healthy has a lot of research behind that.
Right.
It actually works and stuff happens with it. So the whole point is being smart about your body, being responsible for it. And if you think you need to do something healthier in the long run, you should probably talk to your health professional, because if something sounds too good to be true, odds are it probably is.
And on that note, that was lovely. Thanks very much, Jill, for being on the show.
Thank you very much for having me.
And listeners, if you want to appear on Speaking Up, send us an email to feedback@skepticallyspeaking.com. Put Speaking Up in the subject line, give us a brief rundown of what science or skeptical topic you'd like to talk about, and we'll contact you. It's just that simple. We'll be back in a bit with Dr. Maggie Turnbull, and we'll be discussing whether intelligent life exists elsewhere, or if maybe it's just not into us.
Skeptically Speaking wants you to question everything. To be part of the discussion, call in every Friday from 6 to 7 Mountain Time at 780-492-2577, extension 1. That's 780-492-2577, extension 1. You can also email your questions and comments before or during the show to live@skepticallyspeaking.com, or if you're on Twitter, @skepticalradio. After the show, continue the conversation on our website at skepticallyspeaking.com, or check out our Facebook group. You can also subscribe to our podcast on iTunes, and while you're there, why not add a review of the show? Skeptically Speaking also airs on Citywide LP 99.1 FM in Madison, Wisconsin, Public Reality Radio, WPRR 1680 AM in Grand Rapids, Michigan, Roslyn 101.1 in Roslyn, British Columbia, and on freethoughtradio.com. And now, back to the show.
You're back with Skeptically Speaking, and I'm your host, Desiree Schell. So today we'll be talking about astrophysics with Dr. Maggie Turnbull. Dr. Turnbull is a consulting scientist for NASA's New World Observer, a space telescope mission to discover and study Earth-like planets orbiting nearby stars, and for the MIT Exoplanet-SAT, I hope I said that right, a mission to search for transits of habitable exoplanets. She currently serves as president of the Global Science Institute, a nonprofit organization dedicated to scientific research, education, environmental preservation, and sustainable development. Her background is in astrophysics and biology, specifically in searching for signs of life on other planets. Welcome, Maggie. Thanks very much for being here.
Hi, how are you?
I'm well. Thank you.
Good.
So we'll start off easy and start with what exactly is astrobiology?
Astrobiology is the search for life in the universe. And it's a very wide umbrella, scientifically speaking. So I could just leave it at that, and if you want me to elaborate, I will.
No, that's perfect, actually, because it sounds from the research I was doing the last little while that it's extremely interdisciplinary. There's, It uses geology, chemistry, biology, physics, astronomy, obviously.
Yeah.
And if you want to get more esoteric, quantum mechanics is mentioned. So what role?
Well, there's hardly a scientific discipline, or even any discipline at all, that would not be relevant in some way to this search for life in the universe.
So do all you guys get along? Do you play well with each other?
I would say in general, yes, because when you have a field that's that broad, there isn't a whole lot of competition, turf wars, competition over the minutia. I mean, a lot of times when you get battles between scientists, it's because they're, operating within very confined fields of research and arguing over minutia.
Right.
And in astrobiology, the ideas are so big and there are so very many uncertainties that in general, I would say, yes, we all get along pretty well because everybody's kind of got their own little niche carved out and their own piece of the puzzle that they understand really better than anybody else.
So there seem to be two competing theories in astrobiology, the Copernican principle versus the rare Earth hypothesis, otherwise known as "Are we really that special?" Can you explain those?
Sure, I will try to. Mm-hmm. I have to admit that I don't really think in terms of either of those two principles, but the Copernican principle is basically that there is nothing unusual about our particular location in the universe. The laws of physics are the same everywhere, and so it's not like the Earth occupies some privileged location in the universe. And that is, that works in many ways for scientists, because we can look at other galaxies, other stellar systems, and we can understand the orbits of the stars, for example, because we are using the Copernican idea that the law of gravity is the same there as it is here. Mm-hmm. In astrobiology, then, the extension would be, well, if you have a system similar to ours that is, far away, there's no way that we can rule out the presence of life, and furthermore, life like ours, even intelligent life, because, as we just said, the laws are the same. The ways that materials interact with each other are the same. There's no reason to expect that we should be somehow special in that system, not special. But the rare earth idea is that, on the other hand, yes, the rules are the same everywhere, and the basic building blocks, the materials that you have to work with, are the same everywhere. But in the rare earth idea points out that really the system of life on Earth is entirely unique to our particular arrangement. So you have the Earth; it's at 1 AU distance from the sun. That is a particular situational factor.
Right.
And then you have the Earth that's exactly the size of the Earth. It's not a little bit bigger, a little bit smaller. It has a moon that's at the distance of the moon. It orbits in a solar system that has a big Jupiter out there. And each one of these factors compounds upon everything else to create a situation that may indeed be entirely unique to our solar system.
So an organization like SETI would come down on the Copernican principle side.
I think an organization like SETI is simply saying our choices are to not even try, mm-hmm. or to look and see if, in fact, there are other civilizations out there. Because even though our situation here may be completely unique in terms of the setup of our solar system, for example, you don't know how broad of a range of possibilities would be amenable to life as we know it. I mean, maybe you don't need a big Jupiter out there in order to have an intelligent civilization. Maybe you don't need a moon like ours in order to be able to communicate between the stars. Not all of these factors are going to be limiting factors when it comes to intelligent life.
So now you've worked with SETI. Can you tell us a bit about what they do? I'm sorry, SETI, for listeners who don't know, is the search for extraterrestrial intelligence?
Yep, that's right, the search for extraterrestrial intelligence. And it's actually the SETI Institute is the group that I have worked with. And that's usually what people are referring to when they just say SETI. But there are different groups around the world that are doing SETI research that are not all affiliated with the SETI Institute. The SETI Institute really, I would say, is the group that's doing the most comprehensive search for intelligent signals amongst the stars. But they do also quite a broad range of scientific research that's in general related to astrobiology. So, for example, they have investigators that work on missions to Mars to look for signs of microbial life, past or present microbial life there, and other projects like that.
So now SETI, one of the things that they do is they scan for radio transmissions from space.
Right.
So how exactly do they scan? Where do they decide to scan, and why?
Well, right. Well, you have a lot of choices, and not all that much telescope time.
Yeah, it's a big place out there.
So, yeah, it's a big sky, and what we have to prioritize in some way, and this is where I'm not sure where to categorize this. If you would categorize it under the Copernican umbrella or under the rare earth umbrella, because what we do is we start with looking at systems that are similar to our own. So in a way, we're just saying, well, we know for sure that intelligent life is possible on an Earth-like planet orbiting around a sun-like star.
Right.
And for most, in fact, currently for all the stars that are like the sun, we just don't know if they have planets or not. And the radial velocity searches have at least been able to identify for us many stars that have giant planets orbiting them. But as far as Earth-sized planets, we have no idea. So all we can really do is look at the system, each star, and ask the question, is there anything about it that rules out the possibility, that definitely rules out the possibility of our kind of life? Because we know that our kind of life is capable of communicating between the stars. So that's going to be our starting point.
And that's where you come in. But audience, if you want in on this discussion of, we're going to be discussing HAB stars, space transmissions, and the search for intelligent life. And we're on the line with Dr. Turnbull of both NASA and MIT. Beat that. What have you guys been doing? You can call in at 780-492-2577, extension 1. Email live at skepticallyspeaking.com. Or if you're on Twitter, do tweet us at Skeptical Radio. So now you and Jill Tarter, who incidentally was the inspiration for Jodie Foster's character in the movie Contact, which is awesome, created the catalog of habitable stellar systems. Can you tell us about that?
Sure. The catalog of habitable stellar systems is basically a list of stars that pass the test, the basic test of habitability. What we did was we took all of the stars that were in a particular catalog. It's called the Hipparcos catalog, and that catalog is a result of a European Space Agency space mission, where they actually measured the distances of about 120,000 stars. And knowing the distance to each system is actually really important to everything that I did, because I needed to know how bright is that star really, not just how bright does it look, but how luminous is it actually. And in order to know that, I need to know how far away it is.
Right.
So based on that information, I was able to rule out systems that were, for example, really very, very luminous. Luminous stars just don't live very long. And we applied a basic requirement that this star, each star, has to survive for at least, say, 3 billion years or so. On Earth, it took 4.5 billion years to get a technological civilization. Somewhere else, maybe it won't take so long. But really, the brighter, more massive stars, they don't even live long enough to finish forming planets before they start running out of fuel to burn and eventually explode in a supernova. And none of that is good for life, at least not life as we know it.
We actually have a call.
Okay.
Go ahead. Caller, are you there?
Can you hear me?
Yeah, go ahead, sir.
Hey, it's Nathan.
Hello.
So I was just wondering, what was the implications of finding a planet in the habitable zone around either of the stars in the Alpha Centauri system, or at least either of the primary stars, or even Proxima itself?
Finding a signal or finding a habitable planet?
Finding a habitable planet with life.
Well, I think that would be fascinating. The Alpha Centauri emerges as always one of the top targets, kind of no matter how you look at it. It's the nearest sun-like star. It's only a parsec away. And it is, however, in a triple system, which could be problematic, especially the inner binary, the two stars, A and B, that orbit around each other, actually do get pretty close to each other. So that's problematic for a few different reasons, but one of them is that although planets may have formed in what we call the habitable zone of each one of those individual stars, it may be that because of the two stars interacting with each other, those planets would not be able to collect water and other volatiles from further out in each of their planetary nebulae as they're forming, if that makes any sense. So
they're
it's
more
uncertain.
likely going to be like Dune.
Right. I mean, it's uncertain whether that system would be considered habitable, but there's no way you cannot look because it's only a parsec away. Like I said, that's about, a little over, maybe not just about 4 light years. And it's a star very similar in type to the sun, the primary is. and it's got a slightly fainter secondary in orbit around it, and then a third star, a very faint third star in orbit around the two of those. So the implications of actually finding a habitable planet or a planet in the habitable zone of one of those stars would indicate to me that even in a binary system like that, you can still form planets in the habitable zone. And we would have to investigate further to see if that planet actually was habitable and did have water on it. And if it did, then we would know that somehow planets are able to collect water without needing a lot of input from farther out in their solar system. On Earth, all of our oceans came basically from the asteroid belt, asteroids impacting the Earth and bringing water with them.
All right. Thanks very much, caller.
We actually do have a related email question. Getting not as specific as that one star system, how far away would the closest star system be that may have the best chances of life? So obviously we don't know if it's there or not yet, but how far away is the closest star system with any chance of life at all, for life at all?
Well, then, for any chance at all, I would say definitely Alpha Centauri. Alpha Centauri is the closest star system, and there is a chance that could be a habitable system, so I would point to that one. I mean, as far as stars that have the best chance of life, that is something that is very, very difficult to even begin to try to quantify. Certainly, people have tried. I tried to do that with the catalog of nearby habitable systems, where we applied all these different metrics. Is it in a binary system? Is it still stable, even though it is a binary system? Do either of those stars flare? Does it have enough heavy metal content to have formed planets like the Earth? And so on and so forth. And at the end of the day, there's so many different questions you can ask, and you don't understand which ones are the most important factors, that, again, all you can really do is rule out stars that are definitely bad, and the ones that are left over, they're all good. You can't really rank them.
Since the caller called in with a comment about the habitable zone, I'm going to do a little contest here to keep with both the themes of today's episode. The first person who calls in, emails or tweets, the much cuter definition and name for the habitable zone, some of you know what I'm talking about, will win a freeze-dried astronaut ice cream bar. I'm totally serious. Every time I go to the Science Center, I buy these things. I'm kind of a junkie. So give me the bear-oriented, that's your clue, people. Give me the bear-oriented name of the habitable zone at 780-492-2577, extension 1, live at skepticallyspeaking.com or at Skeptical Radio, and you win. I'm sorry, Maggie, you can't answer because I know you know.
Darn.
So, in your search for habstars, I was reading a lot about the terrestrial planets and the conditions that they need to be considered a habstar. Now, you mentioned luminosity, but mass, color, and age also come into play. Why is that important?
Sure. These things are all related to each other. Age, I already mentioned, we have a minimum requirement that a star has to be able to live at least 3 billion years. But we also have the requirement that the star be 3 billion years old or older. Part of that is due to habitability concerns. We want to make sure that planets really are done forming. They're done having a lot of asteroid impacts that would wipe out all life. And they are in systems that are stable. But another reason for that age requirement of 3 billion years is just purely practical, which is that observationally, we really can't tell the difference between stars of, say, 3 billion years old and 5 billion years old that well, but we can definitely tell when a star is younger than 3 billion years. It sticks out like a sore thumb, so it's easy to rule them out. So it's kind of a practical situation. And then you mentioned mass and color, I think, as well, right?
Yes.
And mass, again, is related to this age requirement because more massive stars, which also are more luminous stars, they just don't live long enough. So it works out to be that stars that are more than about twice the mass of the sun really just don't live long enough to be good homes for life long term, life as we know it.
Right. Carbon-based life.
Right. And then color-wise, color is basically a substitute for temperature. Hotter stars are bluer, and that's another way of identifying more massive, more luminous stars. The bluer, hotter stars are also more luminous and more massive. So it's basically looking at the same criterion through several different angles.
So, exoplanets, that's another one of your specialties, I believe.
Yes.
So can you define what they are, first of all?
Exoplanets are planets that orbit around other stars.
That's it, hey?
Yep, that's it.
Wow, that was succinct. So how do we know that exoplanets exist? Because they aren't usually found via imaging, from what I understand.
Right. Well, they are currently primarily found via the gravitational influence that they exert on their parent star. So, for example, Jupiter, fairly massive planet. Every time it goes around the sun also orbits around the center of mass between the sun and Jupiter. So Jupiter's not really in orbit around the sun. Jupiter's actually in orbit around their center of mass. And this actually, as Jupiter goes around the sun, it also goes around this center of mass, which is actually not very far from the center of the sun. But it's enough that you can see the star wobbling back and forth as Jupiter orbits around. And this is the same in all the other stellar systems that have giant planets in them. So what we can do is look for stars that are wobbling back and forth periodically in a periodic fashion and say, oh, there must be some other unseen massive object in that system, and it's probably something like a giant planet. In a few cases, when astronomers first started finding these things, there were some skeptics who didn't believe that you could just assume that it was a planet and it could be maybe just oscillations inside the star that were making it do that. But then they found one where the planet actually passes in front of the star from our point of view, and you can see that directly. And that tells you where the planet is, the size of the planet, and even in some cases what the planet is made of. So through that technique, we now know of something like at least 200 or more giant exoplanets. As far as terrestrial exoplanets are concerned,
and that was going to be my question, yeah, planets like the Earth, then those planets are too small to exert a detectable influence on the star gravitationally. But there is the hope with the next generation of space telescopes that we might be able to image them directly. Just point the telescope at the system and take a picture and see all the planets in it that are, say, the size of the Earth and larger. So would some of these exoplanets be currently included in the the Habitable Stellar Systems Catalog?
Yeah, that is entirely possible. In fact, if we could choose, if we had a lot of choices, we would definitely want to pick stars out of the nearby habitable systems catalog. The problem is that we're pretty limited as far as imaging technology is concerned. So we're going to do the best we can based on what engineers can conceivably build. And the New Worlds Observer is an example of the kind of mission that would be able to look at about 50 sun-like stars and examine their habitable zones for the presence of Earth-like planets. And in some cases, those stars are going to be really excellent stars straight out of HabCat. In some cases, they may be systems that have, for example, lower metallicity than we would like, not that much iron content, for example, so maybe less likely that they would have formed planets, but they're ideal systems as far as being able to see the habitable zone and detect Earth-like planets, so we're going to look at them anyways.
I think we have an email winner of that contest. Is that correct?
That is true, yes. We have Keith S., who successfully answered the Goldilocks zone.
Nice.
Yay, Keith.
And we will give out a shout out to Ryan, our intern, who isn't in studio tonight. He doesn't actually get to win, and he realized that when he sent me the answer, but I'm going to give him a little. Maybe next time we're at the Space and Science Center, I'll buy him one anyway.
We have a rule here that nobody who's involved with the show is allowed to win prizes. Callers again, the number is 780-492-2577, extension 1. Please do call in with questions about life, the universe, and are we really the only game in town? So I want to get into some sort of speculative stuff. So we were talking about being carbon-based life forms. So we do assume that that's kind of what we're looking for when we talk about life. But what else could fall into the life category?
Right. Well, first of all, I would say that I consider us to be water-based life forms.
Gotcha.
Carbon kind of, yes, we are carbon-based. It's aqueous carbon chemistry that keeps us going. But water seems to be the limiting factor for all life on Earth. If you don't have water, it doesn't matter how much carbon you have, you don't have life.
Right.
So I would say we're water-based, and that requirement of water, liquid water, is the underlying requirement for the entire catalog of habitable stellar systems. That defines where the habitable zone is going to be. Now, as far as other, carbon-based versus silicon-based, to me, the question is, but what is the limiting factor that you will only find in a certain part of the habitable zone? If silicon-based life doesn't need water, or instead needs, say, ammonia, or it needs methane, then that sets up a habitable zone in a different part of the solar system. So we would have to judge stars according to that. But given that we don't know anything about silicon-based life, if there even is such a thing, I'm not saying that there isn't. I'm just saying that we don't have any information at all about what that would mean in terms of ruling out target stars to search for signals.
Well, would we even be able to identify that it was life in all situations? Or would it appear as if it was not?
Yeah, I think that's a great question. I mean, the definition of life itself is something that, philosophers and scientists could argue about until the end of time. Even if you assume water-based, just defining what life is exactly, because water does not equal life. I mean, water is not alive by most people's definition. So how do you define it? And as soon as you start defining it in terms of chemicals and materials, then you're just in completely muddy waters, because you can have all the ingredients necessary. You can even arrange them in the correct order, and you still don't necessarily have life. So, now I don't even know what your original question was. But
that happens often on this show. We actually have an email question that is apparently sort of on this topic.
Yeah, it's actually a very simple, straightforward one. How likely is the idea of panspermia?
And what is panspermia?
Yes.
Let's start with that.
Sure. Panspermia is the idea that life could be transferred between stellar systems. One way that this could occur, for example, would be if, say, we had a huge asteroid impact on Earth, and that impact ejected all kinds of material out into space off of Earth. That has happened in the past. There are probably dinosaur fossils on the moon because of the impact that happened that wiped out all the dinosaurs.
Nice.
But would that impact be strong enough to actually eject material all the way out of the solar system so that it could eventually land on another planet orbiting another star, and furthermore still be biologically viable,
right,
so that it could come back to life when it landed on that planet and start a whole new ecological, geological system on that planet?
Wouldn't it be destroyed by radiation or by, entry to the atmosphere?
Well, sure. I mean, on the way to this other star, this little rock with bugs on it would be subjected to all manner of interstellar radiation, obviously extreme cold of only a couple of degrees Kelvin, and extreme desiccation. All of the water in that rock would be volatilized by ultraviolet radiation from between the stars and other energetic processes. So it would be completely dried out, desiccated life and furthermore, it would take millions, if not billions, of years to get to another star system and land on a planet. And then when it did get to that star system, it would have to pass through that star's solar wind, and it would have to pass through that planet's atmosphere, landing, in a fiery streak through the sky.
Oh, my. See,
on the ground.
This rare Earth theory is
right.
Right.
So,
gotcha.
The calculations have been done just to see if it would be possible to get a rock from the Earth to another planet orbiting another star with any kind of reasonable impact from an asteroid or a comet. And the answer is extremely unlikely, but not totally impossible. But then on top of that, you have to ask whether anything could survive a trip like that. And it seems to me the most likely way that panspermia could happen.
That was the question. Congratulations.
Yeah, and actually survive all that stuff would be for us to launch something and send a probe to another planet orbiting another star and safely land it there. So intelligent life, I think, has a better chance of
spawning intelligent life
around.
Right. Okay. Well, we'll be back in a bit with more on astrobiology.
Next time on Skeptically Speaking, we'll be talking about gender in the skeptical community. It's well known that science and tech fields are still kind of sausage fests, but we see increase in female representation every year. So where are we with that in our community? Are we a swirling microcosm reflecting a societal norm, or are there barriers to women that need to be discussed? What about the brains versus beauty issue? Is it a false dichotomy? Or does bringing sexiness into it just reinforce the stereotypes? This show is all about questioning everything. So join us on the next episode of Skeptically Speaking, every Friday at 6 p.m. Mountain Time, here on CJSR.
And welcome back to Skeptically Speaking, and I'm your host, Desiree Schell. We're here with Dr. Maggie Turnbull, consulting scientist for NASA's New World Observer, the space telescope mission to discover and study Earth-like planets orbiting nearby stars. We've been talking about astrobiology and narrowing down the search for life on other planets. So welcome back. Thanks, Maggie.
Thank you.
I believe we have an email question.
This one's a little closer to home than maybe what we've been talking about all night. It's actually to do with Mars. Apparently, the finding of apparent microbial fossils, and there's some new information that suggests that the Mars lander is sterilizing soil samples as it tests them for organic components. Do you know anything about those developments?
Not a lot, actually. That's not Mars is not really my area of expertise, but if you have a particular question, I can hand wave.
Well, I guess it seems like it has to do with the apparent finding of these microbial fossils. I'm not sure if you follow along with the more specific developments and what they're finding there.
Yeah, I don't know enough about it in order to be able to comment really one way or another on it. I can tell you that I'm a little bit skeptical, since this is a skeptics show. I'm a little bit skeptical of any claim. I'm actually a lot skeptical of any claim that anybody has found fossils on Mars. I would say that the kind of analysis that would be required to reach that sort of conclusion would almost necessarily have to be a sample return mission, so that we can look at the samples here on Earth and see what we've got. But in terms of analyzing samples isotopically and even imaging the samples to look for possibilities, like promising inclusions or other features in different rocks that would look like they could be fossils, that I would believe. I just would be very skeptical about any claim that we've definitely found anything one way or the other on Mars.
Okay. I think we had another email come in there.
All right. Well, there's two parts to this one. It's actually two different questions I have that relate. The first one's just in general about the Drake equation, and more specifically, the other one reads, the universe is something like 14 billion years old. If life can evolve on other planets, given the time and space involved, shouldn't our universe be teeming with life? Isn't this proof that life is very special and we're probably alone in the galaxy? So I think those two are fairly related. And maybe we'll start off just with an explanation of the Drake equations for those who aren't familiar.
Sure. The Drake equation is essentially a set of factors all multiplied by each other that are the probabilities of different important things occurring for life to exist. So, for example, you would start out with the total number of stars. In order to calculate the number of stars that has intelligent life, you would start out with the total number of stars, multiply that by, I don't remember what all the individual factors are in Drake's equation, but by the number, I would refine his equation a lot and say multiply it by all the stars that are of a reasonable age and have reasonably viable lifetime for intelligent life to get going, and how many are in multiple systems. And all the work that I did was basically taking the Drake equation and refining it into much finer bits and pieces. But once he's multiplied the number of stars by the number of stars that could have life, by the number of stars that could have planets, by the number of planets that could support life, and so on and so forth. And at the end, you should end up with how many stars out there have life around them. But of course, we don't know what any of those individual factors are, aside from, say, the number of stars that are out there. And depending on what assumptions you make, you could end up with millions of civilizations out there, or you could end up with zero civilizations out there. And we know there's at least one in our galaxy, so that gives us a lower limit on what the number should be. But there's quite a lot of play in those numbers.
You have an interesting job. Do continue.
The second question about, the universe is so old and there's so many stars, and after all this time, shouldn't it be teeming with life if there is any except for us? Well, the Earth is, 4.5 billion years old, and shouldn't by now we have figured out how to travel to all these other star systems and be colonizing them? I mean, what's the hang-up? That's one of my questions, like how come we haven't gone anywhere? And our transmissions are so pathetically puny that really stars, any system that would have any hope of hearing our leaking transmissions from, cable television or even the oldest little puny radio signals would have to be within 100 light years of us. In astronomers' language, that's only 30 parsecs, and that's nothing. That's like a little pinprick in the galaxy. Beyond that distance, our signals haven't traveled that far, so even if somebody is looking for us, they would not be able to hear us. So I think, first of all, that, you have to have an appreciation for just how vast the universe is and how far apart the individual stars are, and for all the complexities involved in space travel and even just panspermia. It's not at all obvious that it's easy for life to travel between the stars or colonize an entire galaxy. So, I mean, the end of that story is, I really don't think we know. I adopted a position of a true skeptic in that I will not jump into one camp or the other regarding whether or not, until we have seen it, until we have figured it out and actually found something. Now, I don't think it's right to say one way or another.
We're actually racking up the emails here. Go ahead.
Well, just before I jump into that one, I just wanted to go back to the SETI search. If our signals aren't really making that far out, is our assumption with SETI that somebody is beaming some very strong signals in space just to reach us?
They would have to be a powerful, or not necessarily a very powerful signal, but it would have to be an intentionally beamed signal. And there are some strategies for doing this. There are some people at the SETI Institute who do think about these things. If we were to try to make our presence known, for example, there's some things that we might do, like, for example, pick a pulsar in the sky and beam a tightly beamed transmission in the exact opposite direction, so that astronomers on any planets over on that side of the sky that will be observing that pulsar will accidentally see us too and detect our transmission. So you could imagine another civilization that wants its presence to be known doing the same thing, and you would have to, you'd have to be luckily or fortuitously aligned in order to be able to see something like that. But let's not pretend that this is easy. The chances of being able to communicate when you don't know that where the person is that you're trying to communicate with are very slim in a universe that's as big as the one we inhabit.
Right. Now, actually, we have a phone call. Go ahead, caller. Are you there?
Hi.
Hi. Go ahead.
Well, couple things. One about those Mars fossils. When they kind of hit the news, I went and downloaded the pictures and everything and looked at them. And there's actually a set of criteria for evaluating microbe fossils, and they didn't match the criteria. And
okay.
It looks like they were just eroding out of the rock and cracked rock.
Right.
Yeah, and it was Bill Schaft of University of California at Berkeley who came up with the criteria.
Sure.
Yeah.
Good.
Yeah. And
well, he has done a lot of work on terrestrial fossils, very old, billions-of-year-old terrestrial fossils, so he would know. Yeah,
and has written several gigantic volumes on it.
Yeah.
Yeah. And the other thing is Jared Diamond wrote an essay for Natural History magazine about 1990 called Alone in a Crowded Universe, in which he argues that life can be plentiful throughout the universe, but intelligent life is unlikely to evolve. Yeah, what would you say, your comments on that?
I would, I wish I could take a more pointed stance on all of this, but I think that when I began this, I was much more opinionated than I am now. Now I look at my work more, I have more of a circumspect attitude about it, and I look at my work as a process and part of humanity's journey in relating to the universe. I don't necessarily go into this every day with, the aliens are there and we're going to talk to them. It's more of a process of discovery. So I don't have a strong opinion about that. I think it's entirely possible that scenario is correct. I think it's entirely possible that a number of other scenarios are correct as well. But what we can't do, what I think I would not be comfortable with, would be to just say, well, we've been looking for 50 years and we're tired and we're done with this now and we're not going to even try. So
right.
The only way to get a handle on this is to attack it from many different angles at the same time. So SETI is one such angle, and it's so easy to do that there's no way we can't do that. It's inexpensive, it's easy, and if somebody did communicate with us, if we actually got a signal, all of our questions could conceivably be answered in one fell swoop, because they could just tell us if there was life on other planets. They could just tell us about what their planet is like. But since that isn't, necessarily going to happen anytime soon, we have other ways of approaching this problem, and one of those is to try to actually look for habitable Earth-like planets around other stars, and if we find them, we can look for signs of at least microbial life, and we don't have to go there to do it. We can look for signs of, say, oxygen in the atmosphere or other elements in the atmosphere that don't belong there, and try to, investigate further. Are there oceans on this planet? Are there forests and continents on this planet? Does it have seasons? And just try to get a handle on whether the planet would at least be habitable, if not inhabited. So
We
that's
actually
all I
have,
can really say.
which is perfect because we have another caller, and I think we might have time for just that caller.
Yes, I think it's going to go back to the Mars thing. It's Mylan from the Mad Skeptics blog.
Hello, go ahead, sir.
Hi, Dr. Turnbull.
Hi.
I have to challenge you on something. You made a statement earlier having to do with the panspermia concept, and I think that you were engaging in a bit of hyperbole, which could be twisted out of perspective. And you basically said that, well, there might be dinosaur fossils on the moon. And all honestly, that's a statement that can't be supported right now, at least to the best of our understanding. I understand where you're coming
hence
from.
the word might.
Yes,
Look,
yes.
I mean,
but,
there's almost certainly rocks on the moon that used to be on the Earth. And those rocks probably have all kinds of life signs on them.
Yeah, but the problem that I have is when you make statements of that grandeur, let's say, it can be misinterpreted quite easally. There's no evidence of there ever having been anything resembling a fossil on the moon, and there's no evidence that there were rocks capable of transporting portions of dinosaurs, which would have to have been previously fossilized, to the moon. Because
I'm gonna actually just trust that listeners are able to take my comments within context and sort of discern for themselves, what it was that I was trying to say. So you can pick that apart as much as you want, and I'm not going to argue with you about it.
And on that note, thanks very much for calling. So, let me see. I hear we have a good tweet.
Yeah, this might be a good one to wrap up the show with. What part of being an astrobiologist is the most rewarding?
Oh, that is a good end of show tweet. Whoever did that, who sent that?
I have their real name up here. Let me get their Twitter name up. Jonathan Abrams.
Thanks, Jonathan.
Well, I would have to say that on a daily basis, the absolutely most rewarding thing for me is to be able to work with all the different scientists and engineers that I do work with. For example, just on the New Worlds Observer, we have so many different people providing their expertise, and every single one of them is just a top quality thinker. And every day I'm so grateful for everybody's input and willingness to communicate what seems to them like a very basic idea to other scientists who have never heard of that before. So this mixing and intermingling of ideas coming from different disciplines is just it's not only just exciting and stimulating, but there's something about it that just is building a really strong, cordial, friendly community of scientists all across the world.
Perfect. And you need to send this show to them, because if they hear that, you'll get more Christmas presents.
Yeah.
And that's our time for the day. Thanks very much, Dr. Turnbull, for being
here. Thank you. This was a lot of fun. Thank you.
It was our pleasure to have you here.
And thanks to everyone who called and emailed, and thanks to Mike for the on-air work, Sean for supervising, and we miss Ryan and his phone foo. Thanks also to new guy, Josh Hull from Toronto, who's doing all the show editing from here on in. So if you liked this episode, please do go download it on iTunes, and while you're there, you can subscribe to the show and you can write a review. A quick one, like 1 or 2 lines even. Please. You can also visit our website at skepticallyspeaking.com. That's it for now, and we'll see you next week on Skeptically Speaking.
South America does not exist. The moon is painted on the sky. Things sometimes fall up, but you never see. And everything you believe is a lie.
Dinosaurs were invented by God as a test. don't run.